Assalamu alaikum guys, welcome back to e-learning. I hope you are doing good, staying home and staying safe. Today's lecture is about normal distribution. If you recall, in the last lecture we studied continuous random variables, and I went on to finish the lecture at uniform distribution, right? So a very important distribution related to the continuous random variables is normal distribution. So today I will go through this distribution which has a lot of applications. So let's recall what we did in continuous random variable. If you recall, a random variable that can take any possible value, right? Because discrete random variable takes on only integers, right? And it's on a given interval is called a continuous random variable. I gave a lot of details in previous lectures, so here I'm just recalling them. For example, speed of car. Speed of car cannot be from 1 to 2 or 10 to 20, 30. It touches every single point of the speed, right, of the speedometer. So similarly, heights of people, they can be in intervals, lengths and areas, electricity consumption. These type of things are not given in integer form, right? They are usually given in intervals. So a continuous random variable is not specified at a specific value, right? Instead, it is given over an interval of values. The probability of single value is equal to 0. We did it in detail in last lecture. Anyway, today I am discussing about normal curve. What is a normal curve? So any curve like this is called a normal curve, right? For example, if you have height of students, if x is the random variable that gives you height of students, this will be a normal distribution if its graph looks like this. Okay. Similarly, the temperature of some city in the month of November also looks like this. So these type of curves are called normal curves. A variable is said to be normally distributed. A variable, of course continuous variable, is said to be normally distributed variable, or is said to have a normal distribution, right, if it has a shape of a normal curve, which we defined above, right? So if your curve has this type of shape, we call it a normal variable, almost this type of shape. Okay, so a normal distribution and hence a normal curve is completely determined by the mean and the standard deviation. Always remember. So if you recall, when we study binomial distribution in discrete case, I said n number of trials and p probability of success are the parameters. It means your binomial distribution is completely determined by n and p. Similarly, Poisson distribution. Then we did uniform distribution, and I said in uniform distribution, the length of interval b and a, right, that should be given to obtain a uniform distribution. So here in normal curve, you need mean and standard deviation. Okay, all these curves, this green curve, red curve, and this light orange curve, these are all normal curves. Okay, and you see here the mean is -2 and variance is 1. Here mean is 3. You see, mean is the middle value. You see here, see, mean is the middle, topmost value is the mean. Mean is 2. Here mean is 3. So you see, topmost value is at 3 here. Okay, so this is your mean. Similarly, here your mean is 9, topmost value. So mean is 9. You remember that sigma is standard deviation. It gives you the spread of the data. If sigma is small, data is not very much spread. You see, data is very narrow, not much spread. Sigma is 1, see, double. It is 1/2, it is 1, and it is little spread. And now standard deviation is 2, and it's very, very spread, you see. So see, if sigma is big, it will have this type of flat shape. If sigma is small, it will be tall shape. Okay, and if sigma is normal, then it should be a normal nominal curve. Okay, mean only gives you the position on x-axis where you stand. If you change the mean, it will just go to the right or left. You see, if mean was 3, mean is 9, it means you went to the right. Mean is -2, you went to the left. But here, when sigma is bigger, you are more spread. If sigma is smaller, you are less spread. Okay, so that's how mean and variance give you the shape of the normal curve. Now, there are some properties attached. The area under the normal curve. Okay, the probabilities in this normal distribution are related to the area under the curve. The probability of a normal random variable at a single value is always 0. And why it is always 0? Because this is the probability distribution of continuous random variable, and continuous random variable does not give you the probability at single value, so it has to be 0. We always find the probability of normal random variable in the interval. Okay, why? Because again it's a continuous random variable, so we have to obtain in a interval. And the probability of normal random variable between any 2 points A and B is the area under the curve between A and B. If 2 points are given, for example, this point 6.5 and 8.6 maybe, right? If you want to find the probability between these two numbers, you have to calculate this area, this shaded area. So this area is exactly the probability. Okay, if you want to find the area under this curve, right, then you have to find the area. So the area, if you calculate the whole area from this to this plus to minus infinity, it has to be 1. Why? Because the total probability is 1. Because probability is the same as area, right? So if the area under the whole curve has to be 1 because it gives you the total probability. So this whole area is 1. So if you pick any two numbers and try to find the area, it will be less than 1. So it's not easy to find the area, because you remember in continuous random variable we need to find the probability from the PDF, right? And if you recall, the PDF of this continuous random variable is 1 over 2 pi sigma, okay, square root e to the power minus x minus mu over sigma whole square. This is your PDF for normal distribution, okay, and x goes from minus infinity to infinity. All right, so it's not easy. Now you recall, you cannot integrate. Remember when we found the probability was the integration. So if I integrate this function, it is not possible. Why? The reason is it's e to the power minus x square. You cannot integrate e to the power x square or minus x square. There is no integration. So it's very hard to integrate here. So we have to go to some other method to find the probabilities. Okay. So before going to that, we have to define a standard normal variable or a standard normal distribution. Okay. So basically that is also a normal distribution, but it is standardized. Okay, we will fix the mean and variance of a normal distribution. That will give you a standard normal distribution or standard normal curve. It's the same thing. A normally distributed variable having the mean of 0 and the standard deviation of 1 is called a standard normal distribution. You see, we fixed mean and the standard deviation. So if your mu is, otherwise mu can be anything. But if I say that mu has to be 0 and sigma is 1, it means I am fixing everything around this point. So it means my center of this distribution will always be at the origin. Okay, and because we are also fixing standard deviation to be equal to 1, so it will not be very tall or it will not be very flat. Okay, it will be very smooth, normally placed curve. You see, not very tall, not very flat, right in the middle. Okay, so that's the reason we are defining this standard normal distribution. But now, what is the relationship between any normal distribution and the standard normal distribution? So any normal distribution will be given to me with any mu and any sigma, right? These are free. So we will define a transformation from x to our random variable z, which will have mean of 0 and standard deviation 1. So this z will have mean 0 and standard deviation 1. X can have any mu and any sigma. Okay, so I need a transformation from x to z. So let me define that. The standard, or we can say that the standardized version of a normally distributed random variable x is x minus mu divided by sigma. Okay, and now if you recall the properties which I studied in a lecture which is called, what was the name, discrete random variable. In discrete random variable we used a property that if you have a linear combination of x, then it will become the linear combination of expected value of x. A and b will stay there, so you will just take the expectation of this x. If I use this property on z, you can see that expected value of z will be expected value of x minus mu over sigma. 1 over sigma is constant. So here if I continue with that, it's 1 over sigma will come out, and you will take the mean of expected value of x, and minus mu will remain as it is, right? Because it's b remains as it is. Now e to the power x is mu, so you see mu minus mu is 0, so expected value of z is 0. Similarly, you can prove that the variance of this distribution is 1. Okay, so whenever x has a normal distribution with mean mu and standard deviation sigma, then z will always have mean 0 and standard deviation 1. Okay, no matter what is given for x. Okay, so this will always be 0 and 1. Okay, so this new variable has 0 mean and standard deviation 1. So I proved for mean. You can prove it for standard deviation as well. So what is the benefit? Let's say if 3 different standard normal distributions are given to me. You see, the first one with mean mu and sigma 1, second with means 3 and sigma 1 by 2, third with mean 9 and sigma 2, right? So see, this is better, right? This one is very tall and this one is very flat. When you convert them to z, right, here z will be different. Here z will be x minus 2 by 1, x minus mu by sigma. Mu and sigma are this. Here x minus mu by sigma will become x minus 3 over 1 by 2. Here it will become x minus 9 by 2, because these are the values of sigma. You see, all 3 different distributions have been converted to a standard normal distribution which is the same for all. You see, which is same for all, 0 mean and unit variance. Okay, so no matter what shape your original normal distribution is having, after this transformation, your z will always have this shape with 0 mean and unit variance. That's why we call it standardized distribution, standard normal distribution. Now what is the benefit? Benefit is there are tables. People have made tables for the areas of standard normal distribution. If you have a standard normal distribution with mean 0 and sigma 1, then you can find the areas under this curve with the help of those table. I will show you the table as well. So let x be a normally distributed variable with mean mu and standard deviation sigma, right? And let a be any 2 real numbers where a is less than b. Of course, we are talking about the interval, so left side has to be smaller. The probability that x lies between a and b, which we state like this, probability of x between a and b is the same as the probability that z lies between a minus mu by sigma and b minus mu by sigma, right? Because we are getting 2 values, a and b. So x minus mu over sigma is equal to z, right? So if I replace x by a, then it will give me the corresponding z value for a, right? So if I replace a here, a minus mu by sigma will be the corresponding z value. And if I replace b here, right, it will give me corresponding b minus mu by sigma. So now these values are in z. Okay, so x is between a and b, or z is between these 2 values, is the same thing. Okay, so my original distribution was this with mu and sigma. So my x was between a and b. right? Now when I converted this A to this Z value, A minus mu by sigma, and this B to my Z value, B minus mu by sigma, now my mu is 0. Here mu is 0, right? So this probability between A and B under this curve is the same as this area under these two values, between these two values under the standard normal curves. So they give you exactly the same area. This area and this area is always the same. So here whenever your x lies between A and B, your Z will lie between these two values. Now what is the benefit? Benefit is that these values are given in the table. This area is given in the table. Okay. So what are the properties of standard normal distribution? Property 1 is total area under the standard normal curve is 1. Okay. The standard normal curve extends from infinity in both directions. It looks like that it is from -3. It is not from -3. Okay. This is going till infinity. If I continue, it is going till infinity. It is going till infinity. But it is very, very close to x-axis. So the probability is almost 0 here. Area is almost 0. Area is almost 0 here. So most of the area is between them. Almost 99% area is covered here. Okay. So very less area in other corners. The third property is the standard normal curve is symmetric about 0. Symmetric means it is the same on both sides, on left side and on the right side. It's exactly the same. You see, the curve is exactly the same on both sides. That's what we call symmetry. The area, almost all the area under the normal curves is between -3 and 3. Okay, as I'm saying, 99% area lies between -3 and 3. So it's almost 0 on the left and right. Let's see an example. How to find the area to the left of a specified Z value, Z value. If a Z value is given, how can I find the area on the left? Okay. If you look at the tables, a table gives you the area at the left. This is the table which is given in your book, which I posted online, Walpole's probability book, right? On page number 735. At the end of the book, this is the area under the normal curve is given. You can see here, it is written area under the normal curve. Okay, so here you can easily see that this gives you the area to the left of Z value. So if I pick, and it's given in only up to 2 digits, you see 3.4. And if you look at the top row, it is 0.04. It means if I pick this value will be -3.44. Okay. And if you pick, let's say this value, 1.0 and 0, 1, 2, 3, 4, 5. So this is 1.05. So if I take the value -1.05, it will give me the area to the left of this. If I take the right end point, let's say +3, you see almost all the area to the left. If I take 3.49, it gives you 0.998. 99.98% area is on the left of 3.49. Okay, so almost all the area is under this one. So now what is the value here? 1.23. So we are looking for the area to the left of 1.23. So what you will do, you will see 1.2 on the left. This is -1/2. I'm not looking for this. I'm looking for +1/2. So if you look at 1.2 here, right, and 3 at the column, this is 3, right? So if you come down here, so this is the intersection, you see. This is the intersection from 1.2 under the fourth column. You see the first column is 0.00. Sometimes we make this mistake. We say that, okay, this is 1.2, 1, 2, 3. This is not 1.3, this is 1.22. Okay, the fourth column will give you 3. So this is 0.8907. So if I go back to my picture where I left off, where was that example? This one, right? So you see 0.8907. So this is the area which I just shown you from the table. Okay, so this gives you the area to the left of 1.23, this whole area. All right, so let's see another one. If you have to find the area to the right of some specific point. Now table does not give you the right area. Okay, if you look at this point z.076 in the table, it will give you the opposite area, this area, right? Because table gives you the left area. So how to find the right area? I know that the total area from here to here is 1. So what I will do, I will subtract this area from 1 to get the right side area. Because the total area is 1. If I subtract this one, I will get the right side area. Okay, so the area on the right will be 1 minus the area to the left of 0.76. Okay, so let me show you how I got 0.76 is 0.7764. So let me go to 0.76. This is the normal table. 0.76. Now 0.7 on the left. This is 0.7 on the left, and 6 is here. Okay, so see 0.7764. 0.7 under 6. So 0.7764. Okay, so see 0.7764. But 0.7764 is the area to the left. You see here. It's the area to the left. So to find the area on the right, I have to subtract this area from 1 to get the other side. Now, if I want to find the area between two specified z values, not to the right or to the left, in between two values, you see, these two values are given and I want between them. Okay. Now, if I look this area in the table, it gives me the area to the left, right? If I look at this point in the table, it will give me area to the left of this point. Now I want to stop here. It means from this bigger area, I will subtract the smaller area. Okay, so I will this is area 1, this is area 2. So I will subtract this smaller area 2 from the 1. I will subtract this whole, this is the big area, this is the small area. So if I subtract this portion, if I delete this portion, I will only get from here to here. Okay, so between two values. So if I look at this value in the table, I will get, if I look at this value in the table 0.6 under 8, I will get 0.2483. If I look at 1.82, I will get 0.9656. So if I subtract this smaller from this bigger one, I will get the area between two curves, this area, which is the shaded one. Okay, so these are the three possibilities. On the left, directly from the table. On the right, 1 minus from the table. Between two values means get two probabilities from the table, subtract the smaller one from the bigger one. Okay, so that's how you can find the area. Okay, so this is also the probability, not just the area. Okay, so now if z value is given, it's very easy, right? But if y values, x values are given, then we have to convert this to z first. So you can, as an activity, you can find these four probabilities, very easy probabilities. You can easily do that. Let's go back to the normal distribution, not the standardized normal. Now it's a normally distributed variable. So to determine the percentage or probability of normally distributed variable, I have to follow these 4 steps. First of all, sketch the normal curve associated with the variable. Then shade the region of interest and mark its x values. Then find the z-scores for the x values of step 2, and then use the table to find the area of the standard normal z-scores in step 3. So let's see an example. He said IQ's intelligence quotients, IQ level is related to the intelligence, are normally distributed with mean of 100 and standard deviation of 16. Determine the percentage of people who have IQs between 150 and 140. So what was the first step? First step was make a curve, right? You can make only standard curve if you want. It's your choice. But anyway, let x be the IQ level of a randomly selected person. So x is a random variable, continuous random variable, which has a normal distribution. Now you see the mean is given. This is your mean. So this is your mu, and this is your sigma, right? So your mu is 100 and sigma is 16. These two things are given to you. Now we said that sketch the normal curve and shade the region of interest. Now if I sketch a normal curve, it does not have to be very accurate because normal is normal. I don't know whether it's very tall or it's very flat. Don't worry about that. Now mu 100 should be right in the middle, right? At the highest point here is the mean value. So I got 100 right in the middle here, and sigma is 16. Sigma cannot be shown, of course, in the, because it gives you the spread. We are interested in x values. Now my x is 115 and 140. 100 is in the middle. It means both 115 and 140 will be on the right side of the mean. So this is 115 and 140. So this is the area which I am looking for, between 140. Now the fourth step was find the z-scores. We sketched the normal curve, we shade the region of interest. Now I will find the z-scores. Z values are z-scores. How to find z-scores? I know that my x, random variable x, is with mean mu and sigma standard deviation. So this is my z-scores. If x has a normal distribution with mean mu and standard deviation sigma, then z is x minus mu by sigma. Now what are the values of x given? The first value of x is 115. So if you replace 115 and 140 here, you will get the z-scores corresponding to 114. So here we have calculated them. So if x is equal to 115, I will just replace 115 in my formula. Z is equal to x minus mu by sigma. Mu is 100, sigma is 16. If you calculate 0.94 will be the value of z. So here I stated the value of z as well. So if x is 115, then z is 0.94. Similarly, if x is 140, then your z will be 140 minus mu divided by sigma, and it gives you 2.5. I got the value of z, 2.5. Now because this is the third case, finding the probability or finding the area between two values. So what I will do, I will look at these two values in the table. This value will give me the area to the left, and this also gives me area to the left. So what we will do, we will subtract the smaller one from the bigger one. So if I subtract this thing from this whole one, I will get this remaining portion from here to here. Alright, so this will be my required area. So if you go to the normal table and find the values at 0.94 and at 2.5, it will give you, let me show you from the table, 0.94, 2.50. So 0.94 is here, this is 0.9, 0.901234. This is 0.94, 0.8264. And second was 2.5. 2.5 is this, 2.5. So it means 2.50. 0 is the first column. So 0.9938 and 0.8264. These are the two values. So we will subtract 0.8264 from 0.99238. That will give me the required probability, or required area, or required percentage, whatever you want to call it. So here I got 0.9938. You see, this is the area to the left of 2.50. See, z less than 2.50 means there is no left bound. So I'm going to minus infinity. And z less than 0.94 means we are going to the left of 0.94 up till minus infinity. So this is the area to the left of 2.5, area to the left of 0.94. If you subtract the left area from the right, you get 0.1674. Okay, so because he asked us the percentage of the people who have IQ levels between 115 and 140, so we will multiply this by 100 to get the percentage. So 0.1674 is the probability of being between 115 and 140. If I multiply this by 100, I'll get 16.74% of the people will have IQ levels between 150 and 140. All right, let's see another example. Let me read through it. We have a training program designed to upgrade the supervisory skills of production line supervisors. Because the program is self-administered, supervisors required different number of hours to complete the program. It's a training thing, so of course they have to complete number of hours of training. A study of past participants indicate that the mean length, you see, whenever you are reading a normal distribution problem, you are looking for mean and standard deviation. So here you see he gave us the mean length of time spent on the program is 500 hours. So this is my mu. And that this normally distributed random variable, he also mentioned in the question that this is a normal distribution question. So my random variable has a normal distribution and standard deviation of 100 hours. So mean is 500, sigma is 100. So I got two values. Now these are all questions and we can answer one by one. What is the probability that a candidate selected at random will require fewer than 580 hours? Means less than 580 hours. Okay. So here the question is, what is the probability that my x is less than 580? Okay. The second one is, what is the probability that a participant selected at random will require more than 700 hours, right? It means I am being asked what is the probability that x is greater than 700, right? Here in the third part, what is the probability that it will take between 500 and 650 hours to complete? So the question is, what is the probability that x is between 500 and 650? And similarly, this is probability that x either takes less than 300 or takes more than 700. You see, so I cannot write them as one interval. Less than 300 and more than 700. These are two separate intervals. So I will find the probabilities separately and add them up. Okay, so let's start. First of all, we have to write the random variable because in the question there is no variable mentioned. Okay, so we will say that x is our normal random variable which is given in the question. So x equals the number of hours spent by a candidate in that training program. And because in the question this told us that this kind of random variable will have a normal distribution. So x is normally distributed random variable with mean is equal to 500 as I mentioned, and standard deviation is equal to 100. So right away I can write the standard normal variable. So after this we can write that, okay, then my standard normal variable will become x minus mu, which is 500, divided by sigma, which is 100. Now if you ask me anything, I will replace x here and find the value of z. All right, so what is the probability that, this is the first question, what is the probability that, and you know that over there I wrote what is the probability that x is less than 500, right? Fewer than 500 hours are needed to complete the program. So x less than 500, it means 580 should be converted to z score first. Okay, so if I convert 580 to z, I have to replace 580 here in x. So 580 minus mu by sigma gives you 0.8. Right, now this is my 580 which is 0.8 and I'm interested in the value less than 0.8. So my table directly will give you the probability of this area because table gives you the area to the left. So if I just see this value 0.80 in the table, it will give me 0.7881. Now in the second part it was more than 700. So more than 700 means I'm interested to the right side of 700. And you remember, right side does not come directly from the table. If I look at this 700 in the table, first of all, I will convert 700 into z-score, that is 2. So if you look in the table 2.00, it will give you the probability to the left. So how I will find the probability to the right? By subtracting it from the 1. So this probability will be 1 minus probability of z less than 2.00. So this comes directly from the table and we will subtract. So from the table, probability at 2.00 is 0.9772. If you subtract it from 1, because it's the right side, area is on the right side of the point, so we have to subtract the area on the left from 1. So this is the probability required. Now between two values 500 and 650, so again we will convert 500 into z-score and similarly 650 into z-score. So these are the two values. Now I have to find the probability between them. So if you look at 0.00 in the z-score, if you want to write the z values here, this is x. So if you want to write z values, this is 0 and this is 1.5. Okay, so if you look at 0 in the table, it will give you 0.5. Of course 0 is right in the middle, so half of the probability is on the left. And if you look at 1.5 in the table, this whole probability will be 0.9332. Okay, so I will subtract 0.5 from 9332 and this is the probability between 500 and 650. Now two tails, because he said now what is the probability that the candidate will either take less than 300 hours or more than 700 hours. These are two separate areas now. You see, less than 300 is the tail on the left and greater than 700 is the tail on the right. So I cannot make one interval for them, right? So I will have to write two intervals. So x less than 300 and or x greater than 700. So for or we have a plus. So I will add these two areas. So if you replace 300 in z, I will get -2, and if you replace 700 in z, we get +2. It means I need the area on the left of -2. So here these are the values of x. So if we write z, this is 2 and this is -2. So I need the area to the left of -2 and I need area to the right of -2. So how you will find the area to the right of -2? I will subtract the area to the left of 2 from 1, and here I will get directly. I don't have to subtract because left side area is directly given in the table. So we will take this directly, but the greater area will be 1 minus area to the left. Now if you look at the tables, this is the area at -2 and this is the area at +2. Now we have to add these two areas. It is 0.0456. All right, so you have to remember the steps in dealing with these type of problems. When x is a normal random variable with mean mu and variance or standard deviation sigma or variance sigma square, we can write mathematically as this as well. X has a normal distribution. We use this sign. Having a normal distribution with mean mu and standard deviation sigma, right? Then your z transformation, which is x minus mu by sigma, also has a normal distribution but with mean 0 and standard deviation 1. That's why we call it standard normal distribution. So whatever values of mu and sigma are given, you will replace them here and it will automatically give you a standard normal variable. Then any area, any values which are given to you for x, you need to convert all the values a in z and b in z, right? So replace the values of a by the value of z at a and b by the value of b, or you can say that z-score of b. So then these both areas are exactly equal. X between AB and Z between ZA and ZB. They will exactly give you the same area. If you make picture, it's good. You can do it without it as well. But if you make this curve, then you can easily see that where I have to subtract from one or which value should be subtracted from the other. Directly it can give you mistakes. So this is ZA and ZB. These are the Z values. Of course, X is mu here and X is B here and X is A here. Exactly same area, okay? And then look at the values of ZA and ZB in the table and subtract from one or subtract from bigger value, the smaller one. According to those three conditions, you can find the area. All right, so hopefully this is understood. If you have any questions, you can send me in the WhatsApp group. I will also post practice problems as well as the assignment from continuous random variables as well, especially from normal distribution. Try to solve them as soon as possible, and if you have any questions, send me through WhatsApp. I will try to answer as soon as possible. So till then, bye from me. Stay home, stay safe.